So welcome back to the discussion portion of the economic geology of lunar and asteroid resources. Keanna is going to talk about Steve Deutsch's discussion of where the interesting, well, where asteroid parent bodies are coming from and how they formed. And the nice thing about this, these sessions is that I learn a little bit from every talk, but I actually learned quite a bit from Steve's talk this time. So I'm looking forward to the discussion. So Keanna, you're on. I'm sorry that not all the systems work properly.
Well, you know.
You just have to roll with the issues that come up.
Hello, I'm Keanna, and I'm going to tell you about asteroids and meteorites.
Do you need a clicker?
Sure if it will work.
Yeah, if it works, then yes.
I have a brand new one you can try. Still in its packaging. We'll see.
Why don't you just begin and we'll see if we can get these things working.
Okay, sorry, frazzled from this stuff. So there's two asteroid formation models, two competing models. The first one is the classic growth model, where you start with the millimeter-sized particles like the cornblooms, and then you move up to centimeter, meter, and kilometer-sized objects. And the second one is the gravitational collapse model, which is more towards what Steve was talking about with the streaming instability, where you have the millimeter-sized particles, then you have this streaming instability, and he described it as the particles usually in the disk moves faster than the gas, and so the particles that are leading shields the particles behind it, and so what ends up happening is particles behind it doesn't get slowed down as much, and so you have an accumulation of these particles that ends up aggregating, and so within a few orbits you have fast accretion of very large planetismals.
So this is sort of like a, this is a terrible place for this analogy, but it's like a, creating a big snowball. You roll it along a snow surface and it picks up stuff.
Yeah.
Of course, nobody ever does that in Florida, so.
Okay, and so when you have these planetismals, you know, asteroids have a collisional history, so they collide and break up and they form families. And so, though correct me if I'm wrong, Dan, if you know this, but they usually have this, I've heard it described as Yarkovsky cone, which is this V shape.
Yes.
Okay.
So,
all right, good.
So that the effect of various processes, mostly drag from the Yarkovsky effect, will either increase or decrease their semi-major axis, depending upon the vector of depending on their rotation, whether they're prograde or retrograde.
Right. So then you have the parent body, which is usually the one in the lower bottom half of the cone, and then the family members on the top. And so the last picture is basically just explaining what I explained of why initially we had larger bodies instead of the growth method. But obviously, you know, these collisions can deliver meteorites, etc., to Earth through usually the nu 6 resonance. And so we're gonna move on. Yeah. Talking about meteorites. So meteorites are about 4.5 billion years old, and they give us the best clues to the formation of our planets in the solar system. You can divide them into falls and finds. Falls is when you see it enter And then fines is when you fine over time. The falls are usually preferential because they're less weathered and contaminated. And usually, traditionally, they divide them into three classes, which are the iron, stony irons, and stones. But a more useful classification is divide them into primitive and differentiated meteorites. So the primitive ones are the chondrites, and the differentiated ones are the achondrites, stony irons, and irons. Next, this is just a picture of an iron meteorite. I'm going to butcher this name of this pattern, but what's the name of this again?
Go ahead and try.
I know it's something statin pattern, but
It's the Widmanstatten.
Widmanstatten, yes, that's the one.
You did fine.
Next picture.
And
Oh,
never trust any pronunciation that you get from me. Just
you know.
Just saying, because I have imperfect pitch, so I don't pick up the subtle tonal differences that a German would probably, my pronunciation would usually makes Germans cringe, which is the Widmanstatten was coined by a German, so.
Yes, makes sense.
And the Chinese are way too polite to even listen to me. So.
So this is a stony iron. Next picture. And this is a stony. And as you can see, the stony ones are usually like the hardest to find because they look like regular earth rocks. Next one. This is just a breakdown of the primitive and differentiated. So you have the chondrites, you have the carbonaceous, ordinary, enzyme, and the ones you usually the other two. I have no idea. So carbonaceous is broken down into their smaller groups: ordinary, H, L, LL, and the enzyme. You have the stony iron with the palladites and the mesosynerites. The achondrites, we have primitive.
Primitive achondrite.
It's on the next slide. Give me a second. Oh.
You want me to go?
No.
Sorry.
No. We have the HEDs from Vesta, lunar meteorites, and the SNCs from Mars. Now you can go to the next one. So achondrites are igneous rocks formed by the crystallization of the melts on the parent body. You can have them both intrusive and extrusive. They do have breccias. And the most
How do
common
you
group-
tell the difference between an intrusive and extrusive achondrite?
That's a good one.
This is not a very fair question, but this is a. Sure, you can.
Is it maybe how fast it crystallizes? Because if it's intrusive, then it
Yeah.
will cool more slowly.
Yes. And so what is the
size?
mark of,
The
it's the
crystal
size of
structure?
crystals.
Yeah, that's pretty
So bigger crystals are intrusive and smaller crystals are extrusive. And that's how you can tell the difference. Terrestrial rocks too, between intrusive and extrusive. Crystal size, speed of cooling, same process.
Okay, yes. The most common of the HEDs, the hardites, butyrites, and diagenites, which are from Vesta, the SNCs, and then the primitive achondrites. You can't see it?
No, I see. I just don't understand.
It's mostly, the bulk composition is mostly chondritic, but it was partially melted or it experienced recrystallization.
That's not primitive.
Well, this is their definition
Well,
now.
recrystallization can also be something like it was dissolved by water and crystallized. And like we say, aqueously altered things can still be primitive.
Yeah.
Melting.
Partial.
Well, partial. It's how much is how much temperature does it need before it's altered? Because if you don't melt the rock, the like metal in it, then it's still
Well,
not saturated.
typically the first thing that comes out of these rocks is the metal. the base material. I long ago gave up complaining about the terminology in meteoritics
Okay.
because it is, you were quite right to say that this makes no sense at all.
It definitely is confusing.
And
Silly.
this is just, yes.
Okay.
It is. But meteoritics essentially was founded by, shall we say, somewhat large personalities. And they had kind of an idiosyncratic naming system, which has evolved over time, but still has a lot of odd things in it.
What is your take on why astronomy in particular and physics in general, more than most other sciences, refuses to change its nomenclature for things? Like, it would make more sense for electrons to be positive, but...
Oh, heavens. What a shock.
Just to give a general physics example of something that should probably be changed, but has not, simply because Ben Franklin picked it.
Well, same reason we don't use grams when we go to the grocery store and buy meats or fruits. We use pounds.
But
There is a huge conservatism in all of these societies. And physics, being one of the oldest sciences, is probably more affected by that than most. There's a strong correlation between the amount and usefulness, an inverse correlation between, well, there's a strong correlation with the amount, an inverse correlation of the usefulness of scientific terminology relative to the age of that science. So the older the science, the more arcane stuff gets accumulated. And quite often, the less useful it is. So geology is particularly bad on this. But physics is way worse because it's been around a much longer time. And it has a stronger sense of its own rightness.
But chemistry doesn't do this as much, and chemistry is fairly old.
Well, actually, chemistry is younger than geology.
Yeah.
Chemistry was largely invented in the mid-1800s by a lot of people who conveniently died young. And so they
We've
could,
talked about this before. Yeah.
because, well, you know, they did really stupid things. You know,
Somebody had to try it.
one of the characteristics of chemical analysis was taste. Can you imagine that now? And then smell. You know, there's an entire suite of carcinogens that are characterized by their smell. Do you really want to go and smell polycyclics anymore? No. So mercifully in chemistry, you didn't have a bunch of 70 and 80-year-old crotchety men trying to impose silly terminology from their youth.
Interesting.
And so, and you know, I take my hat off to the fact that chemistry maintained their a certain level of viability and youthful vigor, mostly because they killed themselves.
So, do y'all want me to stop on this topic? To have another follow-up question, but it's definitely an aside.
Go ahead.
Okay. So like biology pretty successfully did this recently though with like eukaryotic, bacterial, and archaeal reclassification.
Yeah.
So like why do you think biology was able to do it?
Well, biology was way wrong.
Well, yeah, sure.
Initially, and it just got so embarrassing that they couldn't do this anymore.
Do you think that like if asteroid mining becomes a more common industry, that some of these terms will be more heavily pressured
Like
to
primitive?
become more correct?
Well, actually, they'll either become obsolete or remember that the achondrites are not viewed by anybody as a significant resource.
Yeah.
And so,
But will the fact that like many primitive asteroids are a significant resource be something that like people are like, we need another classification system because you can't lump achondrites in with carbonaceous chondrites.
Well, nobody is.
Okay.
You know, you're calling them primitive achondrites, and that gives you, yes, the wrong impression. But you know, I think what happens to these terms is that they just stop being used. So there was a whole subclassification of ordinary chondrites based on pyroxene subgroups. So could you tell me which ones are the bronzite ordinary chondrites? No, because nobody uses that anymore.
Yeah, I was like, oh, what?
Mercifully. You know, I had to learn this when I was younger, and mercifully nobody else has had to do that. So people just stopped paying attention to crap like primitive achondrite.
All right.
You know, it's,
I can look at that.
yeah.
Thank you all for coming on.
As a quick aside, I wouldn't say that physics has just recently like redefined the kilogram and all that. So they have done
that's
some
true.
stuff.
They redefined
Fundamental.
kilogram?
So
Yeah.
originally it was just a liter of water. Then they defined it as an amount of some metal
It's a
mass
platinum
sitting
bar in Paris.
London, Paris, and they brought them all together and they realized that they've all slowly changed, and now they've defined it based off of like
It's energy now.
So,
Yeah.
yeah.
It's
So all of our fundamental constants got shifted by like the 8 decimal point, but
Yeah, but that should have.
Well,
but now it's
the more
official.
You know,
There's no plus or
you
minus
change
on it.
these
It's
things.
an exact
Yeah.
number.
it's something like how fast an electron travels.
I think it's something with a cesium atom or something, right?
Like some particle travels x distance at the speed of light. That energy translated to mass is a kilogram, which is cool.
Doesn't show up on my scale though.
All right.
Anyway, so enough asides.
You could go to the next. This is just, I know y'all remember this picture.
No,
This
this
is
is gymnasium.
Well, the ones that are with me. So this is just showing you the difference between a differentiated asteroid and undifferentiated. What? Oh, I heard no, and then I was like, probably outside.
Someone outside.
Differentiated asteroid and undifferentiated asteroid. So with the differentiated asteroid, you have the heavier elements of the iron at the core. At that boundary, you have the iron and stone, and then the stone, the lighter elements on the crust. And you can switch. Oh, okay. So we move on to chondrites. Chondrites are samples of the color of gas and dust from which all bodies in the solar system form. They're the most common type of fall, and they can be divided into 3 main classes. They are the carbonaceous, which are rich in volatile elements, including carbon and hydrogen. Ordinary, which are usually volatile depleted, and instantite, which are highly reduced ordinary chondrites.
So before we go on any farther, I should just point out that actually this is a terrible classification because the carbonate, there are 6 carbonaceous subgroups, and most of those are not rich in volatile elements at all. That the CVs, so you're looking at Leoville, or in the COs are essentially slightly carbon-rich ordinary chondrites, and that the characteristics and the mineralogy is almost the same as ordinary chondrites. They're called carbonaceous because they have a little bit of carbon in them, but not very much. And so there are really 2 groups of carbonaceous chondrites. They're the ones that are volatile rich, and they're the ones that are volatile poor. And the resources people don't care a bit about the volatile poor ones. They want the volatiles. And you don't find volatiles in ordinary chondrites. You don't find them in the instantite chondrites. And so they are of reduced interest.
CIs and CMs.
CIs and CMs,
Sea otters maybe?
and a little bit of the CRs, some of the CRs.
Are you gonna?
And that's
talk
about it.
I have a chart with the
Okay,
stuff
cool.
for
I'll
that.
ask my
Let me
question
Okay.
then, 'cause
Oh, sure.
it's
So this is just a example of a chondrite, and you can see those circle things are the chondrules, and then this is the CAI, which I'll explain. Next one. So kind of already said this, but the chondrules are circle bodies that are a few millimeter in diameter. It's molten droplets that formed in the solar nebula, and they cooled very quickly, a matter of hours. In most meteorites, chondrules have been partially or totally destroyed, and more towards the point of the gravitational collapse model. In order to destroy chondrules, it takes a lot of pressure and time, and so that means that these the meteorites were not formed small; they came from larger bodies. Next, this is also a part of chondrites. The amoeboidal olivine aggregates, which are just very fine aggregate olivine that are condensed from high temperature gas. And that's what they look like. Next slide. And these are the CAIs, the calcium aluminum inclusions. They're about approximately the first 5% material to condense from the nebula at high temperature. The most common minerals in the CAIs are anorthite, melalite, perovskite, alumina, spinel, hibonite, calcic peroxine, and phosphorite-rich olivine. They come in different types and forms, and they're formed in different ways. And they're most common to CM and CV chondrites. They're the oldest objects in the solar system, and so their age defines like time zero. And
So why are the calcium aluminum inclusions in such funky shapes? And that's also not a very fair question.
Because they were melted, so they
Yeah.
still
Yeah.
in the space.
Basically, they probably started out more or less spherical,
yeah,
but they continue to react to the solar nebula. And the nebula had all sorts of reactive things going on. And so basically they got kind of eaten up and deformed, and that's why you see them in such funky shapes.
What is the age difference between those and say the CI chondrites? Is it we're talking millions
Well-
of years, tens of millions of years?
Probably the age difference between these guys and say the earliest other things like the achondrites or the irons is probably on the order of less than 1 million years.
So then how do we think the age of like the CAI compares to like say when the Uralites form? Because those supposed to have formed first, right? They're the most.
Well, no, the CII is formed first, and
Yeah.
then you get all the other stuff accumulating after that. So you're not talking very much time, a few million years for this whole process.
Yeah.
skip that one. Go to the next one. So they're also classified by what they call petrologic grade, which is how much they've been modified by the processes in their parent body, and so it's on a scale of 1 to 6. If you have a 3, means it's least modified. 1 and 2 means it was aqueously modified at a low temperature. Grades 4 to 6 means that it was thermally metamorphosized.
I don't like this
You don't like this. Why don't you like the scale?
because you should separate the aqueous alteration and the temperature alteration. They're two different processes. They're interactive.
Yeah.
But
1 and 2 are aqueous and 4 and fix it.
But no, there should be like
So what if
a
you have somebody
scale
that's
for
both?
aqueous and a scale for thermal. Because
Well, this is another feature of meteoritics is, yes, many don't. And it may change someday, but again, this is how people learned it when they were young. And people have a strange affinity for the mistakes of their youth.
Make like the complex number scale, 3
Yeah.
plus 2i.
like a letter and an, I mean, I know there's already subgroups and like you don't want to make the name too long, but there really needs to be something to indicate separately aqueous alteration and temperature alteration, because a lot of crystallization
You
and
mean a
volatile.
completely two different skills.
Yeah, because a lot of organic formation and crystallization is dependent on both aqueous and thermal stuff. And right now it's all kind of like grouped in together. Like most things are C2 that are interesting in my research that have organics, but that's a range of, you know, you think merchant might have been as cold as like 50 C to, you know, I've seen upper estimates for interesting like meteorites that are 300 C. That's a huge range, and they're all C2, which is
Well,
crazy.
But fundamentally, number one, meteoriticists don't care about organics.
Well, that's
they
a
have spent-
mistake.
They have spent decades ignoring organics. And yes, it is a mistake, and it drives me crazy. But you will routinely find a compilation of elemental abundances in carbonaceous chondrites that make no mention of carbon. And you say, well, but you can see there's a lot of carbon there. There's 5% carbon. I said, well, yeah, but my SEM, my microprobe doesn't pick up light elements, so I don't care.
Well, but shouldn't
And-
you care even if you only care about the mineralogy? Because for
Carbon-
meteorites in particular, fine scale temperature differences in aqueous alteration will give you different mineralogy, won't they?
Slightly, but most of these guys come at it from being igneous petrologists. That is, they look at melts and they lose interest if any process is colder than 1500 C.
That's a lot in the solar system, though.
Well, yeah, I'm just telling you the way it is. I don't like it myself. But if you try to extract information from these guys, quite often you don't find what you're, as you've noticed, you don't find what you're looking for because they are fundamentally not interested. And yes, this is a crazy scale and it makes no sense. The grades 4 through 6, well, 3 through 6 are one scale, and the grades 1 and 2 are an entirely different scale. And although the aqueous and thermal metamorphism share the grade 3, one doesn't have anything to do with the other.
Trying to communicate to him. You can keep talking.
Okay, thank you.
Can I ask my
Go ahead. Yes.
Can I ask my side question now? Does anyone know why Tagish Lake is a C2 ungrouped? Because there are different carbonaceous groups.
Oh yeah, well, actually all the interesting stuff, a lot of the interesting stuff in carbonaceous chondrites are ungrouped.
Yeah, but we study Tagish Lake a lot.
Yeah,
And usually we will pick a group because like once things get famous, you want to put a paper out saying like, well, I've classified it, because then you get cited a lot. So like, why has no one picked the group for Tagish
well,
Lake?
because Tagish is all by itself.
Okay.
And
Its own group.
you need at least 2 to make a group.
Hit it with a hammer.
Yeah.
Yeah.
There's one. Reading the Meteoritical Society page on it right now. It's like it's shattered. There's multiple instances of it.
Just a
Well,
reminder,
multiple pieces, yes.
Yeah.
Just a reminder, there are fractional types like type 3.5 instead of 3.4,
Yeah.
right?
Yeah, and that's even more annoying.
Yeah. Because then you're like, okay, but is is a 2.4 more aqueously or more thermally altered than a 2.3? Yes.
And then I've also seen like over 6, like 6.2. Does it go
What does
up
that
to,
mean?
but not including 7?
I have never
So a
seen
7 is an achondrite because it's been
Okay,
completely melted through.
okay.
But so I guess
Well, you see,
a 6 would be really heavily metamorphosed,
another
not quite melted.
feature of meteoritics is this chondral fetish that they indulge in, where you'll get a thin section and you'll spend several months probing a single chondrule to understand how this rock evolved.
But
And I find that for some reason that is highly rewarded in meteoritics and makes very little sense to me.
so, I mean, the edge of the chondrule, its alteration makes sense because it's interacting with the rest of the body.
Sure.
But the interior of the chondrule is highly primitive, right?
Well, the interior of the chondrule will tell you, the idea is that you want to look at how it's altered over time. And the idea is as you go toward the center, you see
Oh, so it's
different
like tree
periods of
rings.
yeah, like trees,
Okay,
different rings of alteration.
that's actually really cool.
Yeah, but, spending 40 years doing that would,
Not my plan.
Ruining people's careers here, Dan.
Right.
well, I have the greatest respect for people that have that level of patience. I would just wish they would find something.
Okay. All right, so,
And I should also say that I'm a fellow of the Meteoritical Society. And I go to Meteoritical Society meetings, and they have some of the best meetings of any meeting I go to.
meaning,
Pardon me?
like, meaning what best thing?
Oh, they have great banquets. They have the best banquets of any organization ever.
Good food.
Well, it was founded by a bunch of people who considered themselves gourmets, and so the food usually is very good, but they go to a great deal of trouble to have really striking venues for their banquets. So the state dining hall in the Czech Republic, the Austrian Royal Riding School, American Museum of Natural History.
Is that the one under the blue whale? Or?
Yeah, I actually sat under the blue whale for one of these. The British Museum. That's a great place to have dinner. Sitting under the Spirit of St. Louis in the Air and Space Museum. So they have great banquets. If you can ever go to a meteoritical society, the meeting is in Glasgow this year. I'm going to try to go.
Is it a more extensive meeting than normal because of the gourmet food?
Not really, no. It's not that bad.
Come on with schemes here. Dan, can I fit in your luggage?
No.
Okay, so these are the types of carbonation chondrites. It's basically telling you what is in their matrix, the petrologic type they fall under, and the size of the chondrules that they have. As you can see, the CMs and COs have small chondrules, CVs are larger chondrules, and CAIs. The CH is metal rich, and the CI is the one with the most water, but it has no chondrules. And this is all going to tie in when we discuss a little bit more about the model Steve did.
Right.
It's going to be quick overview of the next one right here. Oh, we could skip this. I basically said the same. Okay, right. So the CI chondrites are the one that matches the sun for condensable elements. It has no chondrules, and it has a very fine grain matrix, and it has no metal because it's too oxidized.
So you notice where the big depletions are in this. It's in noble gases, which don't chemically bind with anything,
Yes.
and things that are really volatile, like hydrogen and nitrogen. And for some reason, they concentrate lithium, which,
Oh, he was saying that they're destroyed in the sun.
Yeah.
Lithium's broken down.
yeah, okay.
Amy, you have something to say?
Yeah, so isn't Bennu spectrally match best? Doesn't it especially best match CIs, but it's got a lot of like shiny parts so they don't know what it is? Do y'all remember that?
I don't think
Yes, people have said that. And the thing is, though, that remember, you've got a rock that's been sitting, rattling around the solar system for 4.5 billion years, so stuff's going to hit it. You should expect about 5% of the stuff on the surface to be accreted from, random junk. So the shiny parts, relative to the very dark carbonaceous, are the 4 or 5% of other stuff that's banged into it.
Okay, cool. I didn't want to look like a fool in this talk, but I was like, wait, isn't Bennu really shiny? Wasn't that?
Well, I think the people that think it's really shiny are the ones that don't think about asteroid processes
No, that makes perfect
and
sense.
collisional processes.
Impacts from other. It makes great sense.
One interesting thing I'd like to say about the last slide with the lithium is that I guess it'd be kind of difficult to know what the initial amount of lithium in the solar system was without CI contracts. And since the sun destroys them,
Yeah.
it's kind of interesting.
Can't you do a theoretical model of like?
Yeah, you can figure out how much
energy
fusion has
output?
gone through because I think it's broken down in the PP.
The proton
Yeah.
cycle.
Yeah, I don't know how many P's are in there.
2 of them,
Just
I
two.
think.
The class, the class has 3.
Okay, we're done. All right.
Thank you, Keanna.
So, move on to ordinary and instachond, right? With ordinary has the H, L, and LL. And so the H is high metal with low iron oxide. The L is lower metal with higher iron oxide. And LL is lowest metal with the highest oxide. And instatype, we have the ELs and the EHs. ELs are highly reduced silicate, both of them are. The ELs have low iron and the EHs have high iron. We'll go to the next one. All right. So there's evidence that they are short-lived nuclides that exist in meteorites, and basically the evidence for that is the abundances of daughter nuclides in the meteorites that they find. And so the main one we hear about most of the time is the aluminum-26, which is the second one on that list. And so the daughter nuclide that they find is magnesium-26. And so the significance of that is basically evidence that nucleosynthesis happened shortly before the solar system formed. It gives us dating for events in our young solar system, and it gives us a source of energy or heat that differentiated solar system bodies. Switch to the next one. So the aluminum-26 is significant because it has a short half-life and it was abundant enough in the early solar system to provide heat. And this aluminum-26 is also another reason, in addition to the chondrules, why the planetary growth formation method won't work, because it takes a longer time than you would have had aluminum-26 available. And then you can go to the next one. So this is going to be a quick overview. I know it's mad small, I can't see it. But a quick overview of the model Steve and others did.
This is a cool model.
Yeah, he didn't really spend much time on it though. So he basically did a model using the meteorite constraints to figure out where these meteorites formed in the solar system and when they formed and how many CAIs they had. And so this is going to be an upward angle. So he developed this model. Look on the right side. So he has the boundary between where you would accumulate high aluminum 26 and low aluminum 26. He placed the andesite chondrites, the ordinary chondrites, and the carbonaceous chondrites on the map. And so in his model, he basically said that Jupiter migrated into about 3 AU and created this gap that separated the primitive from the differentiated meteorites. And the CIs, as you can see on there, he said formed way out. And Ryan, I think, asked if there was a boundary from when you could accumulate chondrules or not. And so the CIs were way out. And so they couldn't have chondrules in them.
But I think the really significant thing that he pointed out was these things are associated with these pressure maxima
Yeah.
from the orbital gas giant, and that so CI is basically the product of a Saturn pressure maxima versus a Jupiter pressure maxima, which is that's a great insight. It's a hell of an insight.
I think I have like 2 more slides before questions. And so, knowing what we know about these meteorites, we can then attach them to asteroid spectral types. So in the Tholen classification, there's 18 types of spectral types of asteroid, and the main types we have are the S, the sodies, C, carbonaceous, the M, metallics, the P and Ds are large carbonaceous, V is Vesta, E is enstatite, and then classify those into 2 big main groups: the S complexes, which are high albedo, and C complex, which is low albedo. Don't ignore that question. I don't want to ask that. So we're going to go. Let's say I want to answer it. I mean,
you see and I know. I bet at least one other grad student knows too.
One of the main reasons is because a lot of them don't make it through the atmosphere. They just burn up before they get here. So mainly the iron meteorites tend to survive.
That and space weathering. We don't get space weather looking ones because they burn off in the atmosphere, the outside, which is the weathered part.
Also, a lot of our meteorites come from more of the NEAs than any other type. Or isn't that's not true?
From the new six resonance in the asteroid belt.
Oh, that's right.
There definitely is a bias.
Dan looks like you have something to say.
Well, it's just that stuff that makes it to the surface is tougher, so you get relatively strong things. If you getting weak things through the atmosphere is very tough, and there are a few very weak meteorites. And how they made it through the atmosphere is just something I can't explain.
Is having more of you more useful? Like if you have one big rock and it's very fragile, but there's a lot more, so it can ablate.
Yeah, it's something like 90 or 99% of the original asteroid.
Well, somewhere between 85 and 95% of the original mass is lost
Yeah,
in atmospheric
if you
entry.
start off bigger, you're gonna end up with something bigger.
Well, but does that help you survive? Period. Because I mean,
Well,
if you're
your
gonna
problem is
fracture
that
in the atmosphere, too.
you're dealing with a pressure differential between the front and the back of
Yeah.
this this object coming in. You can minimize that by having, say, a shallow trajectory, for instance. But the other thing is that maybe it was full of ice, and the ice gave it more strength than what you find when you pick it up. Because a lot of the really weak ones you can crush in your hand. I've been tempted several times.
Yeah, that's kind of cool. I kind of want to do that now.
Yeah,
It's like
well,
having
that's
like
called
a
that's
$500 a gram
You came all the
sample.
way from space just for me to.
Yeah.
that's what I would call a career-ending move.
It's the call of the void, though.
So you're saying when I'm ready to retire,
Yeah.
that's how I
Yes.
go out with
Go
a
out with a
bang.
bang.
You go out with a bang, be banned
With a
from
crush.
every natural history museum in the world.
But yeah, S&Q asteroids are very similar, except S
Yeah.
looks space weathered, and they both look like ordinary chondrites.
You can pull off meteorites from like the roof of your house. I don't know if anyone's ever seen that. But
Explain.
if you take a strong magnet on the end of like your gutter and then wash your roof, you'll get a whole bunch of stuff attached to it. And they did a study to see how much of that is from. Because you can't really test it and be like, no, is it from space? But you can remove all the other sources and be like, well, you know, factories and things like that. And they figured out that like
Well,
25% of that mass is.
couldn't you check, like, isn't
Well,
all
I don't.
iron that like
Dead
came
as the
around after
He's not
World War II
convinced.
is like seeded with certain radioactive molecules? So like you
Yeah.
have to dig up old stuff. So couldn't you just say like, all right, well, statistically, if it's not bearing, it's iron that's not bearing this radioactive molecule, it is more likely to come from space than be this super strategic
No, it's
reserve.
more likely to come from an old iron-making operation.
Oh, interesting. Okay.
Yeah, remember that people have been making iron since what? The Iron Age.
It's still in the atmosphere?
Yeah.
How long
Well,
does it stay up there?
Well, there's a lot of crap in the atmosphere, and things get tossed up there all the time. I think the meteoritic component of the dust on your roof or the dust in your house is more like 1 part in 1,000.
Still a lot.
Still a lot,
But still surprising.
and there are people with the patience to sort through all of that and make those measurements. But there's still just a lot of particulate matter in the atmosphere, and things like dust storms put a lot of stuff in the atmosphere. So every 2 or 3 years, Florida gets blanketed with African dust, for instance, which is, I was quite amazed that happens, but yeah, it happens.
It's good for the
and,
crops, isn't it?
Pardon me?
Isn't African dust really good for crops?
Keeps the Amazon rainforest.
Yeah.
Yes and no. It also is thought to carry sort of viral plant infections. So
Interesting. Okay.
good for some things, not so good for others.
One other thing to say about asteroids slamming into the atmosphere is that they'll be effectively stopped once they hit their own mass and atmosphere. So if you have something small enough, it can just go into free fall rather than like Chile Banks was going, how fast when it exploding because of all that differential pressure. So if you have, something that's say, small, it can run into its own mass pretty quickly and then just fall from, let's say, 40 kilometers, in which case it'll survive. Rather than, so it's hitting the ground at 200 miles an hour instead of, or less. If it's really small, it could just articulate, but
Yeah.
versus hitting the ground at, a few kilometers a second. Yeah, I mean, those don't happen very often, but,
Well,
or they just explode.
there are like flights that screen dust particulates for like cosmic dust and meteoritic dust.
Yes. There's one of the leading lights of the Meteoritical Society, a guy named Don Brownlee, who had come up with this idea that if you just ran high altitude air through a filter, you would pick up lots of cosmic dust particles. And so he got NASA to buy him his own U-2, which is U-2s fly very high. So he got his own spy plane, to do this, and then had it fly around the world in various places, collect
So
cosmic
you-
dust. And there is a cosmic dust collection, and you can go and look at pictures of these things. And if you have an interesting project, you can write a proposal to study a piece of the cosmic dust collection. And it's just amazing how they transfer this dust, because you need a microscope to see it. So you get this package and you need a microscope to make sure that there's actually anything in it, which would scare me to death.
Yeah, no, no.
Yeah, what is this?
Cosmic dust collection.
Opening what package?
Well,
Remember
you
we
can
had
borrow some of the cosmic dust.
Remember we had that guy give us a talk at the last seminar about like how you can get mailed cosmic dust and how it's very scary because if you drop it, it's gone forever.
Well, it's not gone forever. It's just part of the dust of the floor.
Well, it's gone from scientific knowledge
It's
forever.
gonna be like,
Just
how
never
did you
find
get
it.
more dust than before.
It sounds like
And if
that.
you screw it up, they take a dim view of that, because it is like the property of the United States.
Yeah.
And they spent large amounts of money to get that piece of dust. And that's another reason why you don't want to crush the meteorites to dust.
What if I privately purchase one?
Well, then, you can do whatever you want with it.
Put it on YouTube,
But-
film it, make
Yeah.
all my money back.
Well, the problem is that, as far as I know, there are no privately held CIs. Those are all belong to museums, and usually museums associated with governments that can't take a joke.
Yeah,
So,
I'm trying to get my hands on some very good, the French word that I
or
can't.
orgay,
Orgay, yes.
good luck with that.
I know. Now that I'm been
It's
recorded,
it's actually-
I want to smoosh it.
Actually, there are a couple of places that have a lot of orgay that meteoriticists don't know about. And if you want some orgay, maybe you can appeal to these guys.
Black market.
No, it's
Our French black
actually
bears.
regional museums in France. So there's a regional museum in Toulouse, for instance, that has a big jar of orgay, because orgay fell in that region. And I doubt if anybody's actually approached them to borrow some for science. And then the Paris Natural History Museum has most of it. And
We would be analyzing it in France, so that's probably a bonus.
yeah,
You probably-
if you have a French collaborator.
Yeah.
Oh, that helps a lot.
All right. So I guess this is a more recent view of the asteroid belt and the different types of asteroids in the asteroid belt. And so you can see in the inner belt, you have a mix of the S complexes and the C complex. And the outer belt, you have mostly the C complex. And so we know that the migration of the giant planets, usually that's the theory that they allowed the mixing of these, I guess, two complexes. And then my question would be, what other mechanisms could have caused the mixing of these asteroid spectral types besides giant planet migration?
I mean, they're colliding with each other, so you're basically playing pool up there. Things are getting knocked around.
Resonances.
Yeah, resonances.
Yarkovsky and York effects.
Yes. Anything else? All right.
Do you have anything else, Keanna?
I have another slide and then questions.
Okay, all right.
Go for it.
Okay, thank you. All right. Okay, now working, great. All right. So this is just there's different taxonomic classes for NEAs, and then the fraction of those objects in the NEAs. And so if you look at the right graph, don't look at the left. Look at the right graph, you see that we have a lot of S types. Yeah, a lot of S types. X, and X I think composes of the M, the F, and the P's if I remember. But
EM.
the E's are in the
E's, M's, and P's.
E's, M's, and P's. Okay, right,
Like
that
the
one.
EMP. How can what a great
the-
acronym.
The Q types are known as fresh S types, and so space weathering over time is gonna have them look like the S types, and then you see you have a sampling of the D types, which if you look on the bottom graph, are usually found further out, and so if you look at the overall picture, you realize that the NEA population has a good sampling of the different special types of asteroids. And so, with that being said, now that we know all of this information about meteorites and asteroids, I have a few questions. Well, not a few, quite a few questions. And then we can tackle any of those. Right, all right.
I'm trying over here.
A lot of questions.
Okay, so tying it back to the class. So what types of asteroids would be a potential resource? All right.
I'm gonna say that I think palisade is gonna become a trend when asteroid mining is happening. I think like palisade jewelry, palisade sculptures, palisade countertops. If anyone's seen like the marble with granite countertops is like a new super rich trend. I can see that becoming a hot new item because you'll have large slabs of it, so you can do interesting, innovative things with it. And I think that it will be very highly valued.
Well, the downside is that you don't see many iron countertops for a reason. They tend to rust.
But yeah, but you can like
But a palisade
put a
is
sealant over it.
half iron and half olivine.
Yeah.
Olivine would be a great countertop. But
Oh.
Uh-oh.
I didn't do that.
I know.
I'm just gonna minimum. Where's the mouse?
um,
Oh,
You gotta look on this screen
wow,
over there.
what was the frame rate on this?
Yeah, I think
well, it's got a
people are-
delay because it has to go to Mountain View before it comes
Oh.
back here.
I don't know what happened.
Is this
Oh.
hosted out of Ames?
Go back.
Yeah.
Oh, okay. Interesting.
Go back, go back.
Oh, okay,
Don't
that
look
looks
too
One of
hard.
the one of the other features of some pallasites is they have a small fraction of chlorine minerals. And what happens is that if you get a little bit of moisture in there, the chlorine turns to hydrochloric acid and starts eating away and rusting the iron. And since
Definitely need to
rust
do it.
is, the volume of rust is about double the volume of the original iron, it tends to explode the palisite.
That doesn't sound like a good countertop.
Exploding countertop.
Yes,
But
well,
yours
Good to be
seems-
friends for your friends.
Yeah.
well, it's exploding in geologic time, but essentially it shatters into lots of small pieces.
You're Elon Musk and you have to show off your insane amount of money. How better to do it than a cool meteorite and crystal countertop?
Okay,
I wonder if
well,
it's a
Did it
Martian.
impress
but I think it's reasonable to say that volatile-rich asteroids and then asteroids that are metal-rich would be significant resources.
Okay. Next question. I mean, let's say I want to skip around. What adjustments? So we learned about the lunar environment. Now we're here in the asteroid. We're only in the beginning, but what adjustments will we have to make when dealing with the asteroid environment in comparison to the lunar environment?
Less gravity.
Yes.
It's like basically no gravity.
By like
Yes.
an order of 10,000.
Less.
Well, it was interesting because I think it was, I don't remember who was giving the talk, but I think it was Benu. And I was looking at it and they were like giving some specs on it. I looked up what the gravity was on it and it was like literally 1,000,000 times less.
Yeah.
So I was like, you know, well, what's the escape velocity of that? Like,
Oh, yeah.
basically anything,
Tiny.
to the point that I was like, if you hit it with a
Nothing.
hammer, that's escape velocity.
Are you aware
Guess you
that
can do the
if you
skipping.
had a dirt bike on Phobos, the Martian moon, and you did a sweet trick and like launched, you would probably hit escape velocity and
Well,
leave?
they were saying that a Olympic pole vaulter can put themselves into orbit around Phobos.
Yeah, it's so low, and like that's
Assuming
a
they could run.
it's a large asteroid.
Yeah. Just imagine Deimos. Just lay on the ground and go.
I think it's also a very big difference is like we've focused a lot on the lunar stuff about like where we would put our base and how we would transport back and forth from a base, but you can't build a base on a rubble pile. So that's a pretty big logistical difference.
Asteroids are very weirdly shaped. They can have huge.
Well, just like, yeah, you can't build a base on it though. You can't build a house on an asteroid or, you know, I don't even know if you can like dig into an asteroid and line it and live there.
Yeah, it just
Even
makes
Yeah, I
it
don't think we
harder.
know that much about, I guess, internal structures of asteroids, so that's also
rubbly.
Rubbly.
Rubbly, yeah.
But the things, the ones that you're interested in are probably going to be fairly weak. Even if, you know, you have rocks, these rocks will be things that you can smash fairly easily.
Nice. But yeah, it's definitely maybe a good analogy for terrestrial stuff would be the equivalent between like a normal mine, like where people work and then they travel to the mine, they go into the mine and mine it, and like a deep sea oil rig where people are flown out and they spend a couple weeks there and then they have to fly back to actually like live. Can't
Well, I
grow-
think you're more likely to have basically robotic miners that go out to these relatively small asteroids and clamp onto one end of it and sort of eat their way through.
Are there any plans to like move these into like Lagrange points and mine them there, like transport them in and then do the mining operations?
Well, the issue is energy, and remember these things are, the volatile rich ones that you want are something like 20% volatiles. So why drag the other 80% with you?
Is there any plans to mine like the metal ones? Because my economics undergrad is doing a mock-up right now about like platinum prices.
Yeah, but remember that the platinum in these things are like 5 or 6 grams per ton.
Yeah.
So that's not very much different than the ore grades on Earth.
But it might be
You
something.
know, so
like-
far people are looking at, you know, just the infancy of a mining industry. And so it has a long ways to go. But yeah, I think that that's going to be one of the resources. One of the issues though is being able to find these things reliably in low enough energy orbits that you can get to them.
Is there like a known detected asteroid that we think is a big chunk of metal in near Earth orbit?
That's a Robert Jedicke question. And he will be talking about that. He and I will be talking about prospecting for asteroids.
You always
In a
hear
few
about
weeks.
asteroids that are like, oh, it's hundreds of $1 trillion worth, but like,
Right.
I don't know how big that is. Like,
Yeah, exactly. I have no idea what the sizes are.
$100 trillion worth in something, you know,
I do
20 miles
suspect
across. It's
that
pretty sparse.
the metal meteorites will be useful just as like in situ resource utilization for metal because
They have metal.
you need that. You want to build a spaceship, you probably want to use metal,
Mm-hmm.
at least in part of it.
Wood.
Styrofoam.
Okay, I guess more of the politics. What are the political implications for asteroid mining?
Oh my
Asteroid
god.
mining widened the gap, the wealth gap in America and the world.
That's actually a really interesting question. And my economics undergrad just did a mock-up, and actually if the so a lot of the times you can use platinum as a copper substitution. It does a lot of the same things copper does, but better. And he actually found that if you have the platinum market that's moving the same amount of platinum as it's currently moving copper, you would actually increase the value of both the copper market and the platinum market, which is cool. some of the political implications we're looking at are things like we suspect like lobbying is going to play a really big role in asteroid mining because people are not going to want their markets disrupted. A lot of the rare earth minerals that are going to be brought back right now, the demand far outpaces the supply, so adding to the supply chain probably won't change the price drastically or won't ruin the industry even if the price is changed, just because it'll be in such high demand. If Sarah was here, she could talk about her cool Marxist principles, which is not communism, it's a property rights thing. I haven't sat
Well,
down
yeah,
and
that's what I was
walked
gonna
through
bring
it.
up, is like, you know, you got the space treaty that says you can't own anything in space, but that's really for countries, not for
So
people.
Right.
it
that was the
applies
question I
to
had
it,
when
it
we were-
applies to citizens, except in 2015 the US passed a law exempting its citizens. So we have a specifically contradictory law in place now.
So that plot on the moon I finally own now?
So you can't own property on the moon, but there's nothing anywhere about mineral rights on the moon or asteroids. So likely how this is going to evolve is that you will claim mineral rights for asteroids or lunar property for some time. And then once mining has become established enough to be a real industry, lobbying will kick in and the property rights rules will probably also change. That's not a long-term sustainable international treaty.
I guess going off of what Ryan said. Oh, you have something to say?
Hmm?
You have comment?
Oh, well, I was going to comment that back when the New World was the Western Hemisphere was first discovered, the international structure was that the appeal to the Pope, and the Pope divided the world between Spain and Portugal. And how
On that
long
really
did that
great
work?
line.
How long did that work out?
I think the parallel that you can use is like Antarctica is not owned by anyone, but it's subdivided into like territories that are not owned by
Well, no,
people.
it's not really subdivided into territories, but what happens is that people are establishing scientific bases.
Yeah.
And
Doesn't necessarily mean that like that area belongs to
Right.
like,
Right.
yeah.
yeah, you know, it's if you want to put a scientific base down the coast a little ways from McMurdo Sound, it's kind of pointless because you can make a deal with the folks running McMurdo Sound to provide all the infrastructure. So people just don't duplicate it very much. That said, there are resources in Antarctica. It's just they haven't been thought to be valuable enough to be worth the hassle.
Send ice and penguins.
When you melt some of the ice, things may change.
That's Clive Neal invited Sarah to go. There's going to be a conference on like the policy connections between like deep sea mining, because if you're mining in international waters, that's actually a pretty good analogy for space mining.
Yeah, but there are very few useful resource zones that are actually in international waters these days.
Yeah.
Sarah said this: one way to view property rights is through a Marxist framework of original accumulation of capital. Basically, this is a process of enclosing and privatizing a resource until it can be exploited, which continues until it is exhausted. Historical analogs for this range from feudalism in England to rare earth element mining in African countries. Another interesting connection is seabed law and space mining. And of course, various people have talked about seabed mining for a long time. It just hasn't worked its way to being economic. The whole issue with property rights is the ability to use that as a guarantee that you have access and control of that resource. And how that will work out in lunar or asteroid contexts is something that is hard to say at this time.
I will put out, because this is my favorite part of the International Space Treaty that we have technically signed, And there is a
She said
stipulation. We are American citizens, and we have technically agreed. Is that if you can get somewhere in space and say, "Hi, I'm here to tour the moon base," they have to let you in,
Sure.
which is cool and fun. That you can.
That you have a right to inspection of other people's facilities.
Yeah, I like that you can just barge in and be like, "Hi, I got here."
Yeah, I don't think
It's like
that's
a
going to last
quest.
for very long.
I agree, but I think it's a really, I don't know, I'm definitely romanticizing it, but I think it's really interesting that you can do that in space.
I built a
You gotta
rocket
get there
right now.
first.
Can I dock the ISS?
Yes, technically. If you can get to the
That's gonna
ISS,
put
you
me
can
on
get
first.
into the ISS. That will change the first time that
Someone
happens.
does that.
But for
I just see
now,
Elon Musk coming up like.
Well, but whenever Elon launches something from the States, he gets a permit.
Yeah.
From Department of Commerce and things like that. So if you decide that you just want to take a little excursion to the ISS, you're not going to get the permit.
I'm thinking more of like a third-party operator who's not necessarily now, but decades in the future when space travel is easier. Like showing up somewhere that has limited resources because they only plan on having X number of people on board and being like, "I got here, you have to let me in now." And I think that will,
Yeah, but they don't have to let you stay.
I mean,
You have to go now.
that's true.
It's like your parents showing up unannounced to your
Yeah.
door. Like, all right, just leave.
So does that make space piracy impossible right now?
Well,
You
you
just step
can't
on
take
someone's
stuff.
Piracy is a matter of definition. Depends on your point of view and legal framework.
Because if you step on someone's boat,
Uh-huh.
you're technically legally.
You're a stowaway, not
well,
a pirate.
If
Legally,
you're
you're a
in-
pirate.
International water.
Yeah, international waters, but which space is
Yes.
international something.
Isn't this the whole
International
argument
space.
Mark Watney made in The Martian?
Yes.
Yes.
Yeah.
Correct.
Which is,
If you
How-
launch from something
No, he
that's not
commandeered a
yours,
ship that
yeah.
no one explicitly gave him permission to in international waters. Therefore, he's a space pirate.
oh,
Come on, Dan, you don't know these things?
I don't know. There's
You gotta
one more
watch-
thing I don't know.
You gotta watch
Um,
The Martian because the public.
I did. I
loves
just
it.
I don't remember it. I don't remember that part.
Pretty sad.
You know, and calling yourself a pirate. It's what other people call you that is important.
A lunatic.
See, Sarah says, do we think that asteroid mining would threaten the global south? I don't know what that means.
So I think she's
Threaten
talking.
in terms of widening the wealth gap between the global north and the global south, or
Yes.
exploitation of the global south to support asteroid mining by
Solve
global
the
north.
questions I have here.
Okay. Yeah,
What
probably.
happens to poor countries?
One thing that Phil points out that the first country or group that figures out how to do this is quite likely going to leave everybody far in the dust.
Right,
There's trillion.
exactly.
But basically, that's kind of what happened with the discovery of the Western Hemisphere, was that Spain had been a kind of minor player in Europe until they suddenly discovered they tripled the precious metal supply of the world by stealing it from the Native Americans.
Didn't they crash their own economy though because they flooded it with precious metals?
Well, yes, it's called the resource disease. And Spain has actually only in the last 30 years or so recovered from being a major colonial power. But what happened was they took all this wealth and they decided, well, we'll do all the things that we only dreamed of but could never afford, like try to force Catholicism on the Dutch. Like, why would you want to do that?
Because God. You're saving them. They're gonna go to hell.
Or intervene in German local politics, or establish Spanish dynasties in Italy. Can't you think of something better to use their money with? You know,
Well, didn't they make
the Norwegians, you know, put it all in the bank.
Isn't that where like a lot of the absolutely gorgeous architecture in Europe comes from? Is colonial wealth though? They reinvested it in buildings.
Well, actually, most of the really gorgeous architecture, comes from trading wealth. That is, spices.
Is that
Things
not
with-
colonial exploitation by another name?
Well, I would submit not, because what happened was that traders would be, at least initially, buying all those things with these precious metals that they ripped out of the Western Hemisphere. But if you look at the density of World Heritage Sites, you don't find them in Spain. You find them in Italy and France. And I don't recall the Italian age of colonial expansion.
They conquered Ethiopia briefly.
Yeah, but I think that's after they had all the World Heritage Sites. And I think they pretty quickly realized that was really dumb. So I think that the major advantage is trade, and places like Holland didn't use military force to enforce their trade. They did quite well by just buying stuff and selling stuff.
That's why they lost New Jersey.
I would say that's a fairly clever move. Oh, gee, we lost New Jersey.
Love New Jersey.
Son of a gun.
Only
You know, there were Dutch ports and bases all over the world, but they were mostly interested in trading with the locals. And the problem with North America is the locals just didn't have much they were interested in. Furs.
Do you think that the fact that launching from the equator is the best way to conserve the most amount of fuel, do you think that's going to infuse local economies along the equator?
No.
Right.
Um,
Absolutely not.
Just put a
It
board
had
out there.
well. There's only one launch facility that is near the equator, and that's French Guiana.
Well, there's only one now, but we could build more if like space travel becomes.
Well, sure, but the problem is that what you're doing is you're taking a stack of highly explosive, highly volatile, high technology equipment, and you're shipping it to some other sovereign entity, which may or may not view this with the same reverence that you do.
Hey, French Keanna, you want to be state 51?
Yeah.
Well, the way it works, the reason the French built their launch facility in Guyana was that they own it.
Yeah.
And although the locals have a large degree of autonomy, it's autonomy that comes with the proviso that you don't do. There's this list of things you never do. And one of the things you never do is you never mess with the launch facility. What goes on there is not your problem.
But
And-
doesn't that still infuse the local economy?
Oh yeah, well, it's done very good for Guyana, for that.
For what Guyana? French Guyana.
Pardon me?
For French Guyana?
For French Guyana, yeah.
Oh, yeah.
Yeah, it's brought a lot.
We're next
And
door.
also, it is in the rather extreme interest of the French to make sure that Guyana remains stable and law-abiding and enforce the rule of law. And they enforce the rule of law the old-fashioned way with foreign legionnaires. So,
What about something like a 99-year lease like how Hong Kong was leased to Britain, or
What could go wrong?
Well,
So your solution is just continue colonialism?
well, but if no
Well,
money is getting down there, it makes
No.
economic
Well-
sense to but it seems
Build an
counterintuitive to continue launching from the northern hemisphere when we could be launching from the equator and also
Well,
distributing that wealth a little more
It
evenly.
it does, launching from for instance from Cape Canaveral is not as good as the equator, but it's like 85% as good.
85% of fuel is that's a
Well,
pretty big
remember
saving.
that the percentage you're saving is something like with the equatorial velocity boost, it's like 7 or 8% of velocity of orbital velocity. So it's not that huge. Boeing had this grand idea. You've heard about sea launch?
I have not.
Well, it went out of business about 10 years ago. The idea was that you would put your rocket on a big modified oil exploration platform, and you would drive to the equator. You'd launch at the equator. Basically, you'd have the rocket on this platform, and then you'd have
Assemble?
your support people on a small cruise ship, and you'd have a cruise to the tropics and do your launch. And it was actually a grand idea.
Was this more for the cruise? Like my dad used to work for Conoco, and when the company wives wanted to go down for shopping trips, they would magically need a business trip and need to use the company jet.
Well, no.
Okay.
This was an actual thing.
$10,000
This
for
was the
Um,
80s.
But the problem was that the Boeing was getting their rockets from the Russians,
Oh.
and the U.S. government really didn't like that. And so you could do a few private launches, but the thing was that you wouldn't get any government contracts, and any sort of high-tech private launches would be heavily discouraged.
So,
And so
that's
it
the
went out of
big
business.
I,
But
pro- I promise this is my last question, everyone. But so is that a thing? Like, if SpaceX wanted to build a facility along the equator and do launches from there, they would stop winning as many NASA contracts?
no, well, they're a U.S. company.
Yeah.
They're not Russians, so they would be fine.
Okay.
It's just that the costs of doing that kind of outweigh the benefits of reduced fuel and things. And also, there is a if you're dealing with the U.S. government, it's helpful to have a congressional delegation at your beck and call. And so launching from Florida gives them a bunch of people who are willing to go and harass any administration people that get in their way.
Can I ask one more question, class? Or should I
Go ahead.
stop?
No,
Yes.
go ahead.
So is the fact that Florida a swing state something that like keeps money coming in to?
Oh, sure.
Is that
Sure.
like a significant contributor though, or is it just
Nah.
a nice little bonus?
That's a nice little bonus.
Cool.
You know, the issue is that you're never going to launch from Minnesota.
Yeah.
And Minnesota is a swing state too. So they do have extra favors.
Is
For-
Samoa close to the equator? Could we
Yeah,
go
but
from there?
Samoa's not close to any place else.
That's a good point. You're not wrong.
The other thing is that you have to ship it over, and you have to be able to support the people who are doing the launching.
Yeah, that's true.
And if you have to travel for 14 hours in order to go see a relative, fewer people want to do that.
Depends on the military.
Anyway, well, thank you very much, and we'll enjoy your spring break.